So let me introduce. Now, Dr. Neha is a senior member of IEEE. She is currently working as assistant professor. She is working as assistant professor in the area of electronics and communication engineering at NIIT University, Rajasthan. She did PhD in electronics and engineering and MTech in digital communication, respectively in the year of 2015 and 2008 from Barkatullah University, Bhopal, India, and BTech in electronics and communication engineering from Rajiv Gandhi P. Vidyalaya, Bhopal, India. She has more than 15 years of teaching experience in which she has guided one PhD and 20 MTech students. Her research interest lies in design and fabrication of nano devices and nano communication. She has delivered invited talk at various conferences, international repute. She has published various research articles in reputed journals. She is also serving as master trainer for AICTE UK India Higher Education and Research Initiative. This is a very brief introduction about Dr. Neha, and I would like to welcome Dr. Neha for the session, conducting this session as a session chair. So thank you and welcome, ma'am.
Thank you so much.
So now I request the participants, according to the schedule you have received, one by one, you can share your screen and present your work. So is Pushpa ma'am here? Yes. Amit Sharma ji?
Yes, sir, I am here.
Are you ready with your presentation?
Yes,
sir?
yes, I am ready, sir.
Yes, yes. You can share your screen, sir.
Yeah, sure, sir, I am sharing my screens. My screen is visible.
Yes, sir. Yes.
Good evening to all, and one are present to be here. Myself, Amit Sharma. I am a research scholar in Mechanical Engineering Department, Amity University, Rajasthan. Under in this conference, Innovation Technology Amity 2022, I am going to be highlighted few points on the utilizations of thermal energy with phase change materials. Before the starting of this topic, and that is a very latest topic in a field of energy, because as all our technologists and engineers are focusing is on utilizations of the maximum amount of energy. So during my entire briefing on this topic, I have contained introductions, mechanism of actions, advantages of these mechanism, targets, PCM in environment, sustainability, and conclusion. Before the starting of my topic, just I want to highlight the few points on the energy storage method. As we all know that very well, as an engineer, as a technologist, we can't create energy. We not destroy the energy. We just transform from the one form to another form. Energy. So we are establishing lots of different technology for the best storage of the energy that we can utilize for other purposes also. Energy storage methodology that we are adopting according to the recent scenarios, there is a 3 ways: mechanical energy storage, chemical energy storage, thermal energy storage, biological and magnetic. These 5 ways that we are adopting for the storage of the energy. But which one is more efficient and much more convenient? We have to focus on the thermal energy storage. That is much more convenient according to other. Mechanical energy, chemical energy, thermal, biological, magnetic, each and every fields are too much important. But on the basis of the efficiency and the better utilizations of energy, we are focusing here. So much more important is thermal energy storage. Thermal energy storage is further classified into two categories. First one is a passive methodology, and second one on the basis of the active methodology. Thermal passive methodology is adopted by the following few points, such as the thermal energy, phase change materials in automobiles, thermal comfort textiles, heat sinks in electronics. And the active methodologies is also too much important. But main is the requirement of an efficient packed bed storage system. The whatever the packed bed storage system that we are selecting for the storage a large quantity of the heat, it should be an environment friendly, economic feasibility should be high, low thermal losses, and the completely reversibility of the cycles, stability of the storage material should be very high, and the good heat transfer, heat energy density should also to be very high. Now our focus, we can the components of the packed bed storage systems which are related directly or indirectly to the storage energy storage medium, that is a storage medium, energy transfer mechanisms, contaminated systems, and the storage medium. Basically, lots of different types of thermal energy storage systems work on the sensible storage, sensible heat storage capacity system, latent heat storage systems, and the thermochemical heat energy storage systems. The main important thing is that which type of the phase change materials we are using for to increase the performance of that. So the PCM or the phase change materials are the advanced tools of this generations. These are materials which can store a use or sufficient amount of heat during the phase change and in form of the transient forms also. Carbonized materials, lauric acids, high temperature salts, paraffin wax, and some of others important PCMs that we are searching day by day. The PCMs are the 1 point solutions of the multiple problems. The main role for to utilization of the thermal energy, if suppose that we are releasing the use quantity of the energy in a surrounding, it is creating the problem of the global warming. So the best way to utilize the amount of the heat for the other purposes. So we are focusing on the manufacturing of the packed bed heat storage systems. The concentrated solar power system, that is also a best way for to storage the energy in form by the applications of the PCMs, and that we can utilize for the other purpose according to our requirement. Thermal energy storage are key techniques based on PCMs. The PCMs materials, generally we can use. The most known and used PCM is water. We all are aware that the water is a good PCM, phase change material. It can easily exist in all form, solid, liquid, and gas. If we are using the compositions such as the water salt solutions, the melting temperature is -100 degrees Celsius, -0 degrees Celsius, 100 to 0 degrees Celsius, we can say that. And the critical point is also 100 degree and 0 degrees Celsius. If we will calculate the melting enthalpy of the water with the salt solution, it will be near about to 200 to 300 megajoule per meter cube. These come under latent heat thermal energy storage system, which involves thermal charging or discharging as the PCMs, change from the solid to liquid and vice versa. Other benefits include prevent environment degradations of global warming, etc., and other materials which are available in a markets: paraffins, cathodes, salt hydrates, sugar alcohol, nitrate. These are the few materials also available in a form of the PCM that we can use for the other purposes. These are the few images of the phase change materials, which are the paraffins, salt hydrates, and the sugar alcohols that we are recently using for the storage of the heat in a packed bed heat storage systems. Now the mechanism. Which mechanism is much more important? There are the three basic mechanisms which can be used for the thermal utilizations by using the PCMs, phase change materials. First one is a contactless fluid mechanism, that is also too much important. Second one is a direct contact mechanism, and third one is a dynamic system mechanism. On these three bases, we are achieving the different efficiency. Now the contact lens fluid mechanism, in this a slurry is made. The slurry consists of heat transfer fluid or heat transfer fluid with in form of the capsule. That capsules, when it will come in a contact of the heat, it will start to melt and convert into in a solid liquid form. After that, when we will discharge the heat, it will once again adopt the form of solid. Example, a homogeneous mixture of the water and the encapsulated phase change materials. In this case, the heat transfer fluid will be water, because we know that there is a three modes of the heat transfer: conduction, convection, and the radiation. If the fluid particles is arriving in a contact of the any solid materials, and they are absorbing the heat from the surface, so in such a way the heat is going to be transferred, the Newton's cooling law is applicable. So that is too much important to understand this mechanism, that is known as the contactless fluid mechanism. Now the problem with this mechanism, experimentally it is observed that increasing the amount or concentrations of the encapsulated PCMs not only increasing the heat transfer or heat storage capacity, but also increase the net viscosity of the mixture. We know that the viscosity is a one kind of a resisting capacity, that is a one kind of a resisting force that arises between the two layers of the water or the liquid. While the increase in the heat storage capacity is a desirable trait, the increased viscosity causes serious problem associated with the pumping of the fluid. So we will face the difficulty and the restrictions will be produced, and due to the restrictions of the viscosity, we are not able to store the sufficient quantity of the heat in a packed bed heat storage system. So contactless, that is a main or major problems with this mechanism. Now the direct contact mechanisms is much convenient comparatively to the previous one. In this mechanism, the heat transfer fluids and the PCM are mixed directly without the requirement of making microcapsules of encapsulating the PCMs into granules form. This kind of mechanisms reduce the utilizations of intermediate material with its cost effective. So that is much more convenient comparatively to the previous one. Now third one is a dynamic system mechanism, that is also much more advanced comparatively to the previous one, and that research is going on. We are finding the different mechanism. This one is the third. In this kind of process mechanism, the phase change material is circulated using an external force, which may be electrical pump, at any time when it is undergoing phase change. We are using some external external sources to perform that work. Force convection is the main source of heat transfer. This type of the heat transfer mechanism reduces the losses associated with the rest of the methods of the heat transfer and is stored while utilizing the phase change materials. The small diagram representations is also heat is going to be transferred. We are pumping through the tubes in a form by the tubes in form of the PCMs, and pump we are using as like a external source. Now the advantages of these mechanisms, there is a basically three advantages which are very useful. Increased heat transfer rate for a longer durations, because if suppose that we are storing the energy or heat by any packed bed heat storage system, the transfer rate should be high. No problem of phase segregations as it moves continuously. The compactness factors of the systems is kept constant, as nothing additions has been added in it. No problem is arriving because we are using this separately, and no more extra effort we are providing here. The target applications by doing or by the adoptions of these three mechanisms, the main target of the thermal utilizations of the phase change material by exploiting their heat storage. The heat storage capacity is going to be increases by adopting these three methodologies, and the theme behind thermal utilizations of such materials in industries is that the smoke or other exhaust from the such plants remains a good amount of heat energy, which can be reused with the use of this technology. Otherwise, that was going to be based in a surrounding, and whatever the consumption we are using, we were taking by the raw fuel such as the coal or the diesel, the energy which was going to be releasing by the consumption, by the burning of the fuel, that was going to be waste in a form of the waste, and that heat was going to be escape in a surrounding. That was also creating some pollution, and that was also a major cause of global warming. Not only exhaust operations, but also the machines which generate heat loss can be accommodated with such equipments which can be trap the heat, and the same amount of the heat can be reused for the same or other type of the mechanical operation. If you will see these examples in a boiler, in starting when we were using the boilers in ancient time, the raw material we were using the coal for to produce the fuel, the water was going to be heat up, and the working was too slow for the generations of the steam. But after that we have did some implement after whatever the exhaust gases which were going to be passed away into in a surrounding, that exhaust gases we have utilized for to heat up the water before sending into in a boiler. Suppose that we were sending the water into in a boiler at the 0°C, it will achieve for the conversion into in a steam form. Its temperature will be become from 0 to 100°C. It will take some time. The exhaust gases that we are utilizing for to heat up the water before sending into in a boiler, we are sending the water into in a boiler at the 25°C. Now the temperature difference we have required the 75°C. So in such a way we are utilizing the exhaust gases. So that is the best example that we can understand by the mechanism of the boiler. This one is a layout, basic constructions of the PCM, phase change materials in thermal utilizations. Without the PCMs, there is a three types of the modes of heat. There is a three ways to utilizations of the heat. First one is a sensible heat. Second one is a latent heat storage. In sensible heat storage and latent heat storage, the materials that we will use for in a packed bed heat storage both will be different. In a latent heat storage uses the phase transitions of a material. Usually solid liquid phase change is used by melting and solidifications of the materials. Upon melting, heat is transformed to the material. A strong large amount of heat at constant temperature. The heat is released when the materials is solidified. And the formula we have also, by that we can calculate the total amount of heat which is going to be accumulated during the latent heat storage, that is Q is equal to M into delta S. So that is a general layout or the basic constructions of the PCM materials in thermal utilizations. That is also similar, little bit different by the previous one. Now the PCM utilizations in environmental sustainability. Good heat content of around 500 to 700°C. Similarly, the hydrothermal exhaust of the thermal plants or other plants have heat contents of around 540°C. The heat is not only of economic importance, but also an increasing threat posed to the environment. Presently, around 23% of the total global warming is attributed just due to the industrial exhaust. So we are focusing on the PCM, that we by the use of PCM we can storage the large quantity of the heat inside the packed bed heat storage systems, and we can utilize that heat for the other purposes such as the boiling of the waters and other heat treatment also. The most known as and used PCM is water. Typically materials is also for the latent heat that we can define in a category of the thermal energy system. Now that is a PCM utilization and environment sustainability. That graph is going to be show 0, 0.2, 0.4, 0.6, 0.8 and 1 rise in temperatures with respect to the environment sustainability. Such activities not only devoid us of the natural sources of fresh water also, but also extinct various fish and other animals. We have already crossed 5 major extinctions and are currently on the 6th mass extinctions. About 13% of the species have already been lost, and all these is the just of anthropogenic or human activities. That's why we are focusing on the PCM utilizations in environment sustainability. That is a conclusion. It can conclude it that the PCMs are tools of the modern world of physics and engineering. The various techno-economic environment sustainability benefits being are provided by these materials is the need of the PCMs as the heat exchangers and storage devices can be accommodated as an integral or detachable parts of heat exhaust or plants emitting gaseous products, plants emitting hydrothermal emissions near the heat removing apparatus of small or large machines, and even either the heat removing compartments of small or and large scale machines. That is possible by using some filters during the passing away. Thank you.
Okay.
Thank you so much, ma'am. Thank you so much, sir.
Okay. Is there any question from the audience? Any question?
Yes, audience, you can ask directly here.
Okay, then I have a question that Amit, what is your take on the risks of losses of stability of the solution and deterioration of the encapsulation material?
Basically, ma'am, we are searching, and we, as engineers, we are working on to find out the different types of PCM, because whatever the packed bed heat storage systems we are using recently, there is some limitation capacity. Suppose that we are passing the heat from the packed bed heat storage systems, its capacity is not so much high, because is there some limitations. In ancient time, we were using the clay and any other concrete materials for the storage of the material, but on the scientific basis we are finding some synthetic material, we are making some synthetic materials which absorptivity is too much high.
So how about the efficiency of these PCM materials?
On the
how
basis
they are
of
battling with the conventional ones?
On the basis of the absorptivity, we are trying to build up the highest absorptivity. Whatever the heat we are supplying, on that basis, it will absorb the 100% amount of that, such as a black body, which is a hypothetical body. So on that base, whatever the magnitude we are supplying to that, it should be captured the 100% magnitude of that.
Okay. Thank you.
Thank you, ma'am. Thank you.
Thank you. Yeah, Mr. Yadav, we can move on. Thank you.
Yes, next is PK Srividya. Srividya, please unmute yourself. Are you here? Next participant is PK Srividya. Yes, I can see you in the participant list. If you are ready with your presentation, please share your screen. Srividya, am I audible to you? Okay, if she is facing some problem, next is Gemini Mistry. Gemini?
Yes, sir. Yes, sir.
Can you give your presentation right now?
Yes, sir.
Yeah, you can share your screen.
Okay, sir.
And one more thing for all the participants, please finish your presentation in 10 minutes and rest 2 minutes will be for question and answers. So please be strict with time. Finish your presentation before 10 minutes.
Sir, is it presenting?
Yes, it's
Hello,
it's
sir.
visible. Yeah. Gemini, you can start. It's visible.
Okay. Good afternoon, everyone. Myself, Gemini Mistry. I am the master students at IR Gandhinagar. Today, I am going to present you the topic about recent studies in eukaryotic DNA replication machinery. These are the points which I will cover in future slides. So the replication is the biological process for genome duplication. It involves several replication proteins like helicase, topoisomerase, DNA polymerase, etc. It also has the origin of replication sites, which are the sequence of DNA where the DNA replication starts. As compared to prokaryotes, eukaryotes have the multiple replication origins. There are two methods by which we can detect the origin of replication, either by direct methods or indirect methods. Detection of ORIs are at genome scale is necessary and essential. This is the figure illustrating the DNA replication and its core components. As we know, replication is the bidirectional process. So at initial phase, it made a fork-like structure, which is called as replication fork. DNA replication occurs in 5' to 3' direction. So the one strand can act as leading strand and the another act as lagging strand. In the leading strand, DNA replication occurs in continuous manner and the lagging strand replication occurs in discontinuous manner and form Okazaki fragments. There is a topoisomerase enzyme which reduces the strain in the double helix. There is a helicase enzyme which separate both the strands. There are many SSB proteins are there which ensure that both the strands do not rejoin during the replication process. There is a primase enzyme there which add RNA primer at the initial point, which is expanded by DNA polymerase enzyme. There is also DNA ligase enzyme there, which play a role in gap filling, and the sliding clamp that increase the accessibility of the replication process. However, the replication origin in eukaryotes, so we are mainly interested in the initiation part. The eukaryotic DNA replication initiation divided into two major steps. Selection of appropriate initiation site to form a pre-replication complex and the activation of pre-replication complex to start initiation. As the origin replication complex recognize the replication origin, it binds to the replication origin. As ORC bind to the replication origin, CDC6 and CDT1 are recruited by following the inactive form of MCM227. All these assembly are called as pre-replication complex. After this, cyclin dependent kinase and DD4 dependent kinase comes to the picture. It ensures that this assembly is proper or not and signals the cell cycle to move further to G1 to S phase. The CDK levels increases and the CDC6 and CDT1 phosphorylate and degraded. The CDC45 genes and activate MCM227 recruits the DNA polymerase alpha to act as primase and add 20 nucleotide at the initial point. Further, it expanded by DNA polymerase epsilon and delta by DNA leading strand and lagging strand respectively. There is a replication factor C which is a clamp loader, recognizes the joining between primer and the nucleotide and recruits the pCNA, which is a clamp loader, sliding clamp that ensure the uh, DNA polymerase don't fall off during the replication process, and it increase the processivity. The final addition of TRESLING, a complete activation of helicase complex, and the initiation starts, and further it moves to elongation and termination step. There are many biological methods are there, but we discuss very few here. First one is the DNA fiber analysis. DNA fiber analysis is the oldest among these techniques. In this technique, autoradiography detects the tritiated thymidine introduce nascent DNA strand derived from DNA fibers. Second one is a DNA microarray. In this technique, we reveal the DNA sequence by fluorescently labeled DNA with the combination of microarray based open reading frames. The major disadvantage of this technique is that it is time expensive and the resolution may not be optimum. The third technique is the next generation sequencing. The replication origin found by directly by the sequencing replication intermediate or the new shortly replicating DNA. These deep sequencing methods are highly efficient, low cost, and excellently optimum. The another technique is 2D gel electrophoresis. In this technique, we use complete chromosome. The fact behind this process is non-linear DNA do not travel at same rate as in gel as compared to linear DNA. So the partially unbounded DNA may appear likely to replication origin. So we can map that. The major disadvantage of this technique is we can only map only small amount of DNA origin. The fifth technique is DNA combing. The DNA combing is the technique in which DNA is combed into seleniated cover slip. This technique has been successfully employed to monitor replication, fork enhancement, and origin utilization in budding yeast. There is another technique called single molecule trapping and confocal imaging. In this technique, we mainly focus on mobile protein and somehow pre-replication complex. So we can find replication origin fastly. There are another techniques also like DNase-1 footprinting, electrophoretic mobility assay, SNS assay, etc. Computational method. There are many mathematical and statistical based algorithm based methods are here. These are like online predictors in which we have to put our target sequence and they can give us the maximum possible replication origin site. For yeast, there are 3 possible and online predictors are developed, and for human genome, IORI human are developed. At the latest one in 2021, IORI eukaryotes are developed. The major challenge to identification of ORC is the in eukaryotes, DNA replication initiation site lack the obvious consistent sequence between the species. So it is quite difficult to set the common protocol for biological process as well as computational process among the species. The another challenge is that regarding funding and high profile machinery, because biological methods are very tedious and costlier. So it requires expertise mankind, and a slight error in the process may result in failure of whole the process. Future perspective. However, the vast research was done to specify eukaryotic replication machinery. The much more is left. There are many benefits for replication, identification of replication origin. It may help to understand the evolution process, to find the LEUCA, the common ancestor between the species. It may help to conduct drug development for specific target to cure hereditary disease like Friedreich ataxia, Fragile X syndrome, myotonic dystrophy, Huntington disease, SCF7, etc. These all are the result of repeat expansion during replication process. Identification of ORC also may help in cancer research. Conclusion, the eukaryotic DNA replication is the essential step for maintaining heredity. Is there any error occurred during DNA replication cause drastic changes that leads to cell death or transformation to tumor cells? So a correct recognition reduces the chances of error and helps to understand the cell division and cell cycle regulation. The replication origin can be identified by the both direct and indirect method, but validating those, the validate the result, one can only rely on the biological methods. These are the references which I have used. Thank you.
Okay, thank you, Gemini. Is there any question from the audience? Any question? Okay, so I have a question for you, Gemini. Like how DNA replication machinery can be used as, therapeutic targets for treating bacterial and viral infections or autoimmune disorders?
Ma'am, there is a reverse central dogma process for viruses. So we can
Yes.
use the reverse transcriptase enzyme in virus. So we make RNA, we make complementary DNA from the RNA, information from virus. And for that information, we can move further to target specific viral disorder or autoimmune disorders.
Mm-hmm. Okay. Okay, thank you. That is it from my side. Yeah, over to you, Dr. Yadav.
Okay, yeah, you can unshare your screen, Gemini. Next is Sonam Raghav.
Yes, sir.
Sonam?
Good evening, sir.
Yeah. Very good evening. Very good evening. You can share your screen and start your presentation.
Yeah, sure, sir. So is my screen is visible?
Yes, it's visible.
Can I start?
Yes, sure.
Good evening, everyone. So I am Sonam Raghav from Amity University, Rajasthan, Jaipur. I am pursuing MSc Applied Physics from Amity University, Jaipur. So my topic is metal oxide semiconductor for gas sensing review. So first we will discuss about the content part. So first one we will discuss about the introduction. Second is types of sensor. Third is gas sensing. Then we will discuss about the advantages and disadvantages of metal oxide semiconductor gas sensor. Then we will discuss the mechanism of metal oxide semiconductor gas sensor. Then the effect of oxidizing and reducing gases on the metal oxide sensing mechanism. Then we will discuss about the paper literature. Then future aspects in the metal oxide gas sensor. Then we will discuss conclusion and references. So now first we will discuss about the introduction. So metal oxides based on the different type of sensing elements or sensing mechanism, gas sensor classified into the following different parts. First one is metal oxide gas sensor, resistive gas sensor, optical gas sensor, electrochemical gas sensor, capacitance based gas sensor, calorimetric gas sensor, and acoustic based gas sensor. So metal oxide semiconductor are the first and the major option as gas sensing material, because of its promising and faithful features or characteristics like high stability, small size, low cost, simple observation techniques, broad ranges of sensing applications. But there are some drawbacks also, like these sensors are need high temperature in the range of 200 to 450 degrees Celsius to work efficiently. So when sensor working on high temperature, it decreases the sensitivity and short life of the sensor. Metal oxide semiconductor are also known for their poor selectivity, and also the metal oxide frequently affected to a great extent by material size imprecise due to the nano effect. Materials show unique or special properties at nanoscale, such as electrical properties, go through very remarkable changes for making an excellent sensing material. So now we will discuss the mechanism of the MOS sensor. So here you can see the diagram of the mechanism. So basically the gas sensing mechanism of metal oxide semiconductor is mainly associated to the surface phenomena, which contain gas. Oxygen ions adsorb on the surface of metal oxide semiconductor. Semiconductor nature of metal oxide is important for gas sensing because as you can see here, the semiconductor core and insulating core. So when air molecules come in contact with the crystallographic surface of metal oxide semiconductor, and oxygen ions trap the excited electron from the conduction band and form a depletion layer on the surface of metal oxide semiconductor, as you can see in the diagram. So first one is the semiconducting core, means we all know that semiconducting having a low resistance. So when targeted gas introduced on the surface of the, when oxygen ions introduced on the surface of MOS sensor, then resistance is increases. And when targeted gas introduced on the surface of the MOS, then reducing gas decrease the resistance and oxidizing gas increases the resistance. In P-type oxide semiconductor, we know that electrons are high in concentration, so they form a whole accumulation layer which having a low resistance. And when targeted gas introduces, then resistance increases, and when oxidizing gas is introduces, then resistance decreases. So now we come to the next part of our presentation, paper literature. So first paper is a high triethyl amine with the sensing properties of NiOSNO2 hollow sphere PN heterojunction sensor. So here you can see the first graph, which is a figure 5, show the response of pure SNO2 sensor to 10 ppm triethylamine gas exhibits relatively response of 14.5 at 220 degrees Celsius. And the second one is the composite, which is in black line. So this show the maximum response of 23.3 at 260 degrees Celsius. So you can see the high response of the composite as compared to the pure SNO2. So now in second picture, you can see display the response of curves of sensors to different triethylamine concentration from 2 ppm to 10 ppm. So you can see the variation of the pure SNO2 and the composite of NiSNO, means composite sensor. So remarkable enhancement of sensing characteristics towards triethylamine in the composite sensor. So the response of reached to 270, which is higher than that of pure SNO2 sensor with gas concentration of 100 ppm. Now in next graph, you can see the response and concentration. You can see the high response can also be observed upon the exposure to the triethylamine concentration as low as 2 ppm with a better response about 5.2, indicating a relatively low detection limit. Now in next, you can see the graphs. Both sensor can quickly respond to triethylamine gas. Here you can see for the composite NiOSNO2 and the pure give the response 11 second and 11 second, and recovery time is 34 second and 25 second. So you can see the composite sensor needs larger time to recover than pure SNO2 sensor after remove gas. So in next graph, you can see the response of other different gases on composite sensor is low, but to triethylamine it is high as 48.6, indicating excellent selectivity. So now in next we will discuss about the second paper, which is remarkably enhanced hydrogen sensing of highly ordered SNO2 decorated TiO2 nanotubes. So in first paper you can see, as you can, TiO2 has a smaller work function than SnO2. Transfer of electron from TiO2 to SnO2 would occur, leading to formation of an electron depletion layer at the surface of TiO2, but an electron accumulation layer at the SnO2 surface, which increases resistance. So this also we will discuss in mechanism. So you can see the diagram actually what happened in mechanism. So now in next you can see the graph. The response of the sensor first increased and then decreased with increase of precursor concentration following the order of 0, 2.5, 5, 10 and 20 mm. So you can see for 5 it is maximum in red line. So now in next we will discuss about the 5 continuous cycles to checking the long-term stability of this composite sensor. So which is the response transient in 1000 ppm hydrogen, but also recovery once and then baseline in atmosphere were excellently reproduced. So you can see from all these graph, these proves that the result demonstrated clearly that excellent reproducibility and long-term stability for the 5 mm sensor. So in next we will discuss about the third paper, which is SnO2 based composite type sensor. So in first you can see the behavior means response at different temperature from pure ZnO-SnO2 and the composite of ZnO-SnO2. So you can clearly see the identical behavior of higher response at higher concentration of hydrogen. Now in next graph you can see the response of pure ZnO and SnO2 composite prototype anil at 400 degrees Celsius, 500 degrees Celsius and 700 degrees Celsius upon the exposure of hydrogen in air at various operating temperature. All sensors show identical behavior of higher response of higher concentration of hydrogen. So now in next you can see that response for the different gases. In order to investigate the selectivity, perform sensing studies of composite sensor to other gases like methane and carbon monoxide. Then it was seen clearly that the response of sensor to hydrogen was highest among the other tested gases. Now second graph shows that percentage selectivity of the sensor operated at 150 degrees Celsius to 10,000 ppm of each gases. It can be seen that sensor is most selective to hydrogen. So these are some listed papers from my research. You can see the response time, detected gas and synthesis process and the references also. So these are the different important papers which I selected for presenting. So now we can discuss about the future aspects, what we can do in metal oxide semiconductor sensing field. So the research on the combination of metal oxide semiconductor and 2D material or conducting polymer is still in early stages. So we can work on the composite of metal oxides and polymer and 2D material. Sensing mechanism is need to be further investigated, means we can improve the sensing mechanism also. Researchers should also develop a new design strategy to further optimize the metal oxide semiconductor using new 2D nanomaterials or conducting polymers, making it more suitable for gas sensing. Future efforts are needed to improve selectivity through effective strategies such as surface functionalization and constructing MOS, MOFS structures. Humidity-based gas sensing studies are minimum in number, so we can means we can work on the field that doesn't affect the humidity, means gas sensor doesn't affect by the humidity of our environment. So gas sensing studies of ternary compounds, mean the combination of 3 or more compounds have been studied in detail. So now come to the last conclusion. In this review, we summarize the latest advances in metal oxide semiconductor based gas sensors, including gas sensing mechanism, a series of ways to improve. How can we improve the metal oxide semiconductor sensing characteristics? So now the metal oxide semiconductor based composite material is more favorable for the adsorption and desorption of the target gas, because due to their formation of heterojunction, large specific surface area, and the effectively improve the gas sensitivity of pure metal oxide semiconductor, especially for 2D nanomaterial and conducting polymers or combined with metal oxide semiconductor. Although the metal oxide semiconductor based gas sensor have achieved great progress in past few decades, the selectivity of metal oxide has remained unsatisfactory because the selectivity is not good in metal oxide semiconductor. So we can use the composites of metal oxide with the conducting polymer and 2D which we will discuss also in introduction. So the research on the combination of metal oxide semiconductor and 2D materials is still in early stages, and the sensing mechanism is ambiguous and need to be further investigated. So here are the references which taken by me, and more other also references, but we have to present in our time limit. So thank you.
Good presentation, Sonam. Is there any question for Sonam from the audience? Okay. So, Sonam, can you please tell us what do you understand by the response time of a sensor?
Response time means we have to work on the response time, because there are different papers which I have studied, and there are lots of different timing for response, and there are different formulas also for calculating the response time of any
But
gas.
what exactly is, what do you understand by this term response time?
And when targeted gas come in contact with the sensor, then the gas sensor then the gas sensor shows some changes in it. So by this we can find which type of gas is reacted or not, and by this changing in the gas sensing behavior, response time is get.
Okay. So can you tell me this response should be high or low?
Ma'am, this response time, less response time is better for a good sensor.
Less time. So for specifically for metal oxide semiconductor gas sensors, how do you shorten this response time?
Ma'am, firstly, I think by the composites, ma'am, pure metal oxide, or ma'am, means for the pure metal oxide semiconductor, we can see that there are large response time. So when we work on the composites, means 2D or polymer combining, then we can decrease the response time. And also there are lots of work of different kind, by which we can see there are very less time response time for the gas sensing.
Okay, thank you. Thank you, Sonam.
Thank you, ma'am.
Thank you, Sonam. Next is Pushpa Gotwal ji. Pushpa ji, are you here?
Yes, sir. I'm,
Okay.
yeah, just
You can share your screen.
so fine.
And after Pushpa ma'am, PK Shri Vidya. Shri Vidya, can you hear me?
Yes, sir. Is it visible, sir? Is it visible?
Yeah,
Hello?
it's loading,
Okay.
ma'am. It's loading. Wait a minute. Yes, Pushpa ma'am,
Yeah.
can you unshare and then share it again? It's loading, ma'am.
Okay, sir. Fine.
Yes, PK Shri Vidya, can you confirm your presence? Dr. PK Shri Vidya.
Yes, sir. Is it visible now?
No, it is
Ma'am,
still loading.
Still loading.
Okay.
ma'am.
Okay.
Either Yes, Ajay Kumar. Yes, ma'am. Now your presentation is visible, ma'am.
Yeah, okay, fine. Thank you, sir.
Okay, okay, ma'am.
So very good evening, everyone. So myself, Pushpa, I'm going to present the paper on the review on the PZT-based energy generation tile. So basically, these are the theme line about my PPT. Yeah, so these are the content about the PPT: introduction, motivation, research objective, what are the work done I have done, literature review, conclusion, and references. So basically, the review on the PGT tile, what is the origin behind it? So basically, for the smart campus, I have to design the PGT tile. So here I'm going to define what is a smart campus. Smart campus is basically define the digital online platform that help to manage the university information or data to provide the ease the students and teachers. And what are the sustainable resources? Because I'm reviewing about the PGT tile. So role of the sustainable resources is basically effectively utilization of available resources and design the renewable energy resources. Now, these are the motivation for designing the PGT based style and the review on the same. So basically, I just wanted to utilize the resources which is available to ease the students and teachers and improve the quality of the life, to provide the better learning platform, as well as enhance the research and innovation via collaboration, effective utilization of space and shortage of the natural resources, and to sustain the education in the pandemic situation. So these are the very small examples of smart campus which already implemented in the foreign universities. They are successfully running the smart campus where the energy generation playing a very important role. These are the objective which I have to present it. So here in this particular PPT, I just wanted to present the very brief review about the available PGT tile which is used for the energy generation technique, and some optimization also done which I'm not including in this PPT. So these are the literature review about the available PGT time. So in the last few years, several walking platform using the PGT sensor has been implemented to optimize the power. So as per the study and analysis, material is the important factor to design a tile. So therefore, some comparative analysis of the PGT sensor embedded in the 9 different material like steel, foam, rubber. By that, they analysis using the APM machine. So by that machine, they are able to analysis which kind of force you have to apply it on the PGT tile for getting a maximized power. So as per the research, they concluded PGT tile with the direct force can produce a more voltage under the foam. So foam is the best material for getting a maximum voltage in case of the direct force. And with indirect force under aluminum, you can use that particular material. So there they are discussing about the base materials of the tile is an important factor. Then the next platform reported which generated the energy via the PGT transducer and achieved the maximum output volt 50 volt with respect to 80 Newton force. Then second working platform design using the 72 piezoelectric sensor that arrange in the 8x9, 8 sensor in the row and 9 in the column with the dimension of 450 mm into 450 12 mm, and these are the dimension. It generates 15 to 18 volt and current is a 1 microampere. Then later on, many tiles have reported with a small modification in the arrangement. Among that, one tile having a 9500 microfarad capacitance with the maximum of 63 volt using 54 PGT disk. So many tile have been generated using the different combination of sensor, different arrangement of the sensor. Other tile also generated the output voltage of 40 volt at 75 kg and current 1.5 microampere using 30 PZT and 29 PZT sensor that I also tried. The next tile also designed using the additionally circuit with generating the 450 millivolt power using the parallel connection of the sensor. So here in the tile, many author reported some series connection of the tile, parallel connection of the tile, and some using the parallel series both connection of the tile so that we can get the maximum power. And few tile also have been designed with the tile of the PGT sensor 6x6 in the various combination of sensor, which conclude the parallel connection of the PGT sensor provide the maximum voltage 50 volt at 50 kg load. Further on, few supporting mechanism also developed in context of PGT tile that can enhance the power of the PGT. So that particular supporting mechanism are like we can add some circuitry, that is a boost converter, AC to DC converter, and rectifier circuit. So few paper also enhance the power in that context. And bending mechanism, cantilever support is also the example. So first supporting system was a bending mechanism along with the PGT sensor. It can be designed using the 3D printer technology to generate the maximum voltage 19 volt, 34.4, 15.4 with respect to a different diameter of the PGT sensor. So as we can see, when we increase the diameter, the voltage will be increased with the help of the bending mechanism system. The next supporting system also reported using the PGT sensor along with the wireless technology that is named as the STAP technology, Smart Tile Energy Production Technology. It can implement controlling the lights with the foot movement. So what they are doing, they also having a PGT sensor tile, but they connected this thing in a wireless mode to some appliances like light or fan. So whatever energy is generated, they are directly controlling the devices. So that this name given the STAP technology. The next moment also will be development using the 10 PGT with the side LED that can generate 300 microjoule. It implemented in the foreign university on the staircase. So whenever some energy is generated, that particular light was a blinking. So this kind of supporting mechanism they developed, which can be enhance the power of the PGT sensor. Now again, on the material based PGT also design, PGT material also designed on material basis. Just yeah, so on novel approach also reported for the development of the new PGT material that can be utilized for the building functioning as a renewable resources. So in addition to enhance this power of available PGT sensor, novel PGT material also developed which can generate the maximum output voltage and current 42 volt and 11 microampere for a single step. So my area is not designing about the material, my area is designing about the application. Development part is mine, so I did not bother about the material and all things, but it's required to know for implementing the application development. Now the next new theoretical concept also reported for energy generation using the motion of the various part of the body like ankle, knee, hip. So it can also generate the voltage, and ongoing research proposed new concept to harvest the energy using the hybrid concept. So till now only solar, wind are available. Right now PGT and the dynamo, this technique also available. So somehow to overcome the power problem, we can combine that all things. So this concept is called the hybrid concept. So many theoretical paper I have studied about the same. So further to enhance the power, PGT tile focus on the comparison of the various generation technique and analysis the best suitable method for optimizing the power. Then new era to increase the power, as I said you, hybrid polymer and PGT chip. So that thing they have reported like in 2022. This is the recent one which I have seen. So hybrid polymer and PGT chip which can enhance the power in context of the material. And SOC is already developed. This SOC is they also developed. This is related to material part. Now another method to enhance the PGT based palm and tile optimization. So we can done lots of optimization. Some optimization I also done to maximize the power. So this optimization can perform using artificial neural network or RSM tools. It can at least reduce the cost of your PGT slab. So these are the in a tabular form of the PGT based sensor what I have studied. So these all tiles they already developed PGT based tile with 72 sensor, 54, 29, 236, and some bending mechanisms, STAP technology, novel PGT material. And on the material, if your material is a good, definitely you are able to get the more voltage and current. So if we are getting this particular thing, we are able to design a very nice tile which can generate the more power, because when we are moving to certain platform, we are generating a too much energy. On the staircase regularly we are moving. So that is a very new concept which we can implement if we are getting a good material. Right now with the PGT material, what problem we have it? If we are connecting in the series, we are getting more voltage, less current. Connecting in a parallel, we are getting a more current, less voltage. But to save that particular power, we require the optimum amount of voltage and current so that we can store the same thing in the battery. So that's why we are using the combination of series and parallel. But if we work upon the material, we are able to get the maximum voltage and current which can store. Now these are the tabular form of all the papers which I have studied. So as per the PZT review, I can conclude PZT tile can generate the maximum power. We have to consider some important factor. So applied force is the first factor. Whatever human body weight you are applying, that is the more important factor. Quantity of the sensor. If you increase the quantity of sensor, of course your voltage will be increased. Connection of the sensor means if you are using series connection, parallel connection, that is also important factor. Alignment of the sensor. Either you are aligning your sensor on the center, on the edges, on the tile, that is also the important factor. So while designing the tile, we observe this particular point, and sensor material also. So we have used the PZT material. So many materials are available, ceramic material also available. So we have to choose the material also which can provide the maximum voltage. So as per the important factor and advantage of the design tile can use as an extra backup of the energy generation along with the solar and wind. And in certain condition, if the failure of one sources will be there, this particular other sources can provide the power. And PZT tile is a more suitable at the staircase, railway station and airport, and it can be affordable to install at low cost as compared to solar and wind energy generation technique. So right now, as per LR, I can conclude that part ki PZT is a suitable technique and the low cost and affordable. Many places in the gym, in the doormat, they already implemented that part, but still they having some issues which are not giving that much voltage which is required for a day. Or a simple task we can do it, but we cannot get all the energy via PZT. So I think these are the drawback for this PZT also. So these are the references which I have followed to do the things. Thank you. Is there any question?
Yeah, any question from the audience? Any question from the audience? Okay. Well, in that case, I have a question, Pushpa.
Yes, ma'am.
You know, PZT has been known to us from decades, right? And it is the most exploited piezoelectric ceramic material, right? But still, PZT tiles for energy harvesting purpose have not become commercially viable. What do you think? What are the reasons behind that?
Ma'am, right now I got the same project, DST project, ki I can optimize the tile and dynamo. So as per my research till now, in the PZT case, what I said it ki it's having a breakdown point also, as well as to arrange the things and to get the maximum power via PZT. I think arrangement is the biggest deal. Rather than arranging, if this particular PZT will be available in materialistic form like a flexible electronics chip, like if you have seen the post of the London bridges, they implemented the PZT tile and that tile able to generate the maximum power. But in India, right now we are not able to do the same thing. We cannot commercialize because we don't have such kind of materials and all. So I think the problem is that I'm using a sensor, connection of the sensor. If I'm moving that particular plate, it will not work. So lots of problem is there. So I think if we will design this thing in the flexible plates form, it can generate the maximum power, as well as it will be portable at every places. Right now, whatever I have designed, if I'm moving my tile from one place to another place, connection will be changed. My sensor is movable and I'm not applying a force at right place. Again, I'm not getting the voltage. So that kind of problem we are facing. But the solution which I and ma'am find out, Dipshika ma'am, if we design this thing in a material form, we are designing some particular strip of the PZT. It can be the solution, best solution, but till now we did not work upon it. That solution we got it with the ma'am also.
Okay.
Yeah.
Okay. Thank you.
Thank you, ma'am. Thank you, sir.
Yeah. Over to you, Dr. Yadav.
Thank you. Next is paper ID 43 on behalf of PK Shri Vidya. Who is here? Who will present? P. Srinivasan.
Is also here.
Yeah. You are presenting your paper na, on behalf of.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes,
Yeah,
sir. Yes, yes.
You can share your screen.
Yes, sir. Yes. Good afternoon, everybody. Sir, am I audible?
Yeah, It's visible. You can go to slideshow so that it will become on a full screen.
Sir, this work is about solar water heater with nano.
Listen, Mr. Srinivasan, your audio is echoing. Maybe you have, run this meeting on the two devices.
Now,
can
now
switch
is
off
it okay,
one.
ma'am? Ma'am, now
It
is
is
it okay, ma'am?
and you have to present this in slideshow mode.
Ma'am, is it okay now? I think now it,
Audio is okay, but you have to present this in slideshow mode. You may like to press F5.
Make it a full screen.
okay.
Press F5.
Is it okay now?
Press
You
it,
just
please.
double click here.
Sir, உங்களுது இது பண்ணுங்க சார். இல்ல உங்களுது ஷேர் பண்ணாம.
Yeah, you can. Yes, ma'am. We will manage it. We will manage.
Okay.
ma'am.
You can just there's a small pop-up slideshow. Just
Resume.
just click on this resume slideshow.
On your screen. Yes.
Ah.
Go here. Resume slideshow.
Go to that small blue pop-up. Yes.
Yes. Okay.
Fine.
Okay. Okay.
You may like to start now.
Yeah. So this work is about solar water heater with nano thermal storage bed. So here we have attempted to do same kind of two solar systems. One provided with thermal storage bed, another one without thermal storage bed. So we know that solar heater is important thermal storage system, and we have many modern techniques we are employing to enhance the heat transfer rate to the water, or to retain the heat in our system by insulation method or by another some other methods. So we actually sometimes provide nano coatings for retaining more heat from the sun. And sometimes we use certain materials placed in your flat plate collector, that is in the water. We are using certain materials to retain certain heat. So here we have attempted to provide a bed. Okay, to provide a bed. So the bed will be consisting of nano material having good thermal retention. Good heat transfer retention, in the sense it does not allow the heat to pass very easily. So like that we have tried to. Ma'am, actually the slides are changing.
The introduction that is coming. You're on second slide right now.
Oh, second.
You can continue because time is running. Okay.
Sorry. Okay, ma'am. Is second slide is visible now?
Yes.
Okay.
You just focus on your contribution.
Okay.
Whatever research you have done, and what is the main contribution? Because you have only 8 minutes left.
Yes, sir. Yes. So here actually we have done actual fabrication of two different units. The two units are having same specifications, same glazing materials, container, core work, cylinder, all are same, except one unit is provided with the thermal storage bed, which is filled with a nano copper oxide material. along with some charcoal material also. The readings are taken in 2 weeks time from morning 9 to evening. So we have taken the readings of the water outlet through ordinary thermometer. So we measure the temperature in a very simple way. The unit which is having which is not having that thermal storage bed, the readings are varying around 30 at morning, then 35, 39, 44, 52, 57, 60 like that. Whereas with the storage thermal bed, we have slightly improved performance around minimum 4 degrees Celsius enhancement we are noting because of providing this thermal storage bed. So we conducted these tests in 2 weeks time so that we are able to get the consistent results, and the average values are given here, but the slide is not visible here. Actually, we have done the graph also, graph and tables also we have given, and also the 2 different arrangements of the solar platform systems for this water is also given here. Real-time pictures also we have given here, 2 different models. I think better I can show one slide at a time now. Now it is, I think it is visible now. Okay. So these are the 2 solar thermal system what we have fabricated here. So one is provided with additional bed which is filled with nano copper oxide material, which gives better results compared to the solar water heater without having that bed. So this is the idea. Actually, we could measure the radiation input energy also. Because of not having that provisions, we have done 2 units to measure at the same time, so that we can prove which one is better. By having 2 similar units prepared with the same parameters, we are able to conclude that one unit is giving better results comparing to the other, which is not provided with the thermal storage bed. And so these are different work what we have done during the fabrication, different actual concession. These are the data what we have collected on 2 different weeks. So they are given in graphical form also for the week 1 and the week 2.
Okay,
That's all.
this is it from your side?
That's all, ma'am. That's all our work, ma'am.
Okay. Any question from the audience? Okay. You know that almost 1,360 watts per meter square of solar energy is received by Earth, right?
Yes, ma'am. Yes, ma'am.
What do you think? What are the major bottlenecks in harvesting it?
In thermal related, ma'am, or in photovoltaic related? Actually, enormous heat. We need more area, ma'am. Actually, the main problem with the solar tapping, solar energy tapping is we need more large area for properly tapping.
Sorry, your voice
So
is
that's
breaking.
a major concern. Otherwise, for thermal related or efficient. Ma'am, actually, regarding the solar energy, the main concern is we need a large area required for tapping the energy. either in thermal system or in photovoltaic systems. So we have to go for better photovoltaic conversion systems or better the solar thermal systems, which can absorb more energy from the sun.
So right
From
now,
little area.
what is the
The area is-
maximum? What is the maximum efficiency that we have achieved so far in case of solar cells, photovoltaics?
Photovoltaics maximum efficiency. Maximum around 20 to 32, ma'am. We can go for the nano dyes. We people are doing perovskite cells research is going on for more energy receiving and
Okay. Okay, thank you. This is it from my side. Over to you, Dr. Ashwini. Dr. Ashwini.
Yes, ma'am. So participants.
and multi-wavelength absorption systems also we can consider, ma'am.
Okay, okay. Thank you. Thank you, Srinivas.
Yes, sir. Yes. Thank you, sir. Thank you, ma'am. Thank you, sir. Thank you.
So at the last of this session, ma'am, I again thank you, Neha Tiwari ji, for conducting this session in a very smooth and very fine way, ma'am. Thank you very much for joining with us.
Thank you.
And definitely I will coordinate with you, ma'am, for this judgment sheet.
Score sheet. Yeah, sure.
So thank you. And thank you, everyone. Thank you, all the participants.
Thank you,
For
sir.
presenting-
Thank you, ma'am.
For presenting
Thank you,
your
sir.
work here in this conference. So very soon we will inform you about the next process or about the certificates. Within a week, we will send through your email IDs. So now officially I am ending this session.
Sir.
Thank you.
Okay, thank you, ma'am. Take care.
Okay.
Goodbye,
Okay,
everyone.
bye-bye.